All right, welcome to another day, ladies and gentlemen. Again, today's lesson should be nice and short, really good. Hopefully, it's review as well. So we are looking at rational exponents, and I like ways to remember things. Rational fractional exponents are what we're looking at today. And it is based on properties of exponents. So we're applying what we remembered yesterday or on Monday, whenever you watched that lesson, and applying it today to rational fractional exponents. So we want to remember, first of all, what rational exponents really mean. And so we have, for instance, the square root of x. Well, this is the square root symbol, but more importantly, we can write the square root of x using an exponent, and that would be x to the 1/2. So if you remember, this is what we call the index. Whatever is right inside the little elbow right there, and if there's nothing there, there's always an invisible 2. And then there's always some power, and in this case, that power happens to be a 1, so to the first power. In the same way, if I had cube root of x, well, again, this is x to the first power, and the index is 3. So what I always like to say is whatever the index is, then it's x to some power p. And if you could write it this way, you can also write it the nth root of x to the p, and they mean the same thing. What they really mean is x to the power over index, all right? So whatever that power happens to be, and then divided by whatever the index of the radical is. Power over index. We want to evaluate each expression without a calculator. And remember, you are taking notes on this. You want to highlight the title. You should have written the title and the date, always, always. And then, of course, highlighting the directions. You want to do this without a calculator, but you can certainly, I say that. You're always allowed to use a calculator. But you absolutely should use your calculator to check, always. You want to be able to prove everything using your calculator, all right? It is a good thing. So first of all, we have this little problem here, negative 32 quantity to the negative 4/5 power. Well, first of all, what does a negative exponent do? That's going to create a fraction. That's going to say, hey, drop this whole thing down into the denominator. So that negative exponent creates a fraction, moves it to the denominator, so 1 over. And then I think what I'm going to do is just rewrite this 1 over. What does this 4/5 power mean? Well, that's going to be a 5th root of negative 32 all to the 4th power. You'll notice a 5th root is going to make things a lot smaller. And so I want to do that first because I'm better with smaller numbers. I could have put the 4 on the inside of the radicand, but then I'd have to do negative 32 to the 4th power, which I don't know what that is. It's some huge number. So I'm going to make things smaller. So I'm going to work inside this. The 5th root of negative 32, we want to ask ourselves what times what times what times what times what gives us negative 32? Well, negative 2 times negative 2 times negative 2 times negative 2 times negative 2. 5 times gives me negative 32. The 5th root of 32 is 2. Hopefully you knew that. The 5th root of negative 32 is negative 2. So we evaluated that radical right there, the 5th root of negative 32. And now I'm going to take it to the 4th power. And if you remember, negative 2 times negative 2 times negative 2 times negative 2. That's going to give us a positive result. Got an even number of negatives there, so we get 1/16 for the answer. And over here, same thing. I have a negative exponent, so the first thing I want to do is change this to a fraction. So that is going to be 1 over. Now this is really tricky. Oh, this is crazy. Oh, I didn't think about that before. There's a couple of millions of different ways that you can deal with this. So I'm going to do it this way, only because I can. Negative 1/25 over 27. So now that's positive. Okay, I'll do it that way. So I have 1 over. Now you'll notice my power is a nice positive power now since we flipped it into a fraction. So again, I want to go ahead and try and clean this denominator up. So I'm going to rewrite this. It's a cube root of negative 125 over 27. You'll notice I went ahead and put the negative with the numerator. Top or bottom doesn't really matter, just not both. And then I can think about, well, that's what is the cube root of negative 125? And if you will, the radical property, if you have a giant radical like this, it really is just the cube root of the top over the cube root of the bottom. So just in case you were curious, that is the property. So we can take a giant radical and split it up into 2 little radicals. That's fine. So then the cube root of negative 125 would be negative 5, because negative 5 times negative 5 times negative 5 would give us a negative 125. So we know that works. And the cube root of 27 is 3, because 3 times 3 times 3 is 27. So the root would be 3. All right, and then 1 divided by a fraction. That's really annoying. I hate dividing by fractions. So we don't divide by fractions. If we want to clean this up, we're going to multiply top and bottom by the reciprocal. I normally don't do this way. But again, when we're simplifying fractions, you have to multiply top and bottom. Because in effect, negative 3/5 divided by negative 3/5, well, that's 1. It goes into itself 1 time. So we're multiplying effectively by 1. That doesn't change the value of the fraction we started with. Instead, it just cleans up a little bit. So we have negative 15 over negative 15. Well, negative 15 over negative 15 just cancels itself out as 1. So that goes away. And on top, we have 1 times 3 is 3. 1 times negative 5 is negative 5. So it becomes negative 3/5. This is the definition of a reciprocal right here. 1 over some number is just the reciprocal. So it's a good thing to think about. There are about 1,000 ways to simplify these kinds of questions. And this might not be the best way, but it works. All right. There are simpler ways. There are other ways to do it. Absolutely. But you absolutely want to check these using your calculator. I'm going to go ahead and use the Casio calculator. If you haven't used a Casio before, it's a great little calculator. Often it's actually better than the TI, the Texas Instruments. But again, you are allowed to use both, but you have to know how to work them. So be very, very careful. So first of all, Casio is menu driven. So the menu here, these are all the different things that the Casio can do. And it's almost limitless. It's a really nice calculator for not a lot of money. So we use the graph menu a lot, and we use the run menu a lot. So we're going to go to the regular run math menu. And option and exit are the buttons you really want to know on the Casio here. But for us, this one, just the regular here. Option gives you lots and lots of different options. But we're going to exit. We don't need it. This is a negative 125 over 27. Make sure you use the negative, not subtraction. They're different. So please be very careful with that. So we're going to go ahead and use parentheses and type it just like it is here. Negative 125 divided by 27. So that's that stuff in parentheses. Now, to get the power, you're going to use the caret button. This is the caret button right there. That's a sort of power up is what I say. And on the Casio, you have to use parentheses around this exponent. It doesn't have pretty print like the TI does, but we're going to use negative 1 divided by 3 and put that in parentheses. And then execute. You'll notice you get a fraction. That 0.6 is 3/5, but you can use the fraction decimal button to convert that to a fraction. So we're going to press FD, and you can see it changes it to negative 3 over 5. Our TI does the same thing. So on the TI, we're just going to push on And again, I want to use parentheses. If you don't use parentheses, you might get a different answer. That is not incorrect. Again, we use the caret button, but you can see that this has pretty print, so it actually types it up in an exponent position. So you don't have to use the parentheses. You can see that it's exponent superscript, so a little small size. And again, we get a decimal. And so your calculator, the TI, also in the math menu. So you're going to go to the math menu. And right there, the first thing is convert to a fraction. So I'm just going to push number 1 and enter. And then you can see -3/5. Ladies and gentlemen, please know how to use your calculators. Okay, you have them for a reason. So example 2, again, you can pause these videos, write down any questions that you have. Go rewind, listen again. Like on the last example, you could show, like maybe a question you would ask is, you did it one way. Was there another way to do that rather complicated fraction? That'd be a great question to ask me when you see me again, like tomorrow, Thursday. All right, simplify each expression. Answer should have positive exponents. All right, so again, we have grouping symbols here. This looks kind of bad. I don't like how this was typed, but it is 2/5 all in an exponent. So again, they use parentheses, but really this is just multiplication. Everything is multiplied together. So we're going to multiply our numbers together. We're going to multiply x to the 2/5 together with x to the 1/4. So again, 2 times 6 is just 12, regular numbers, really easy. These have the same base, so we're going to keep the base the same, and then we need to add these exponents. Well, in order to do that, you need a common denominator, but maybe you don't. Maybe you have a calculator that you're allowed to use. So 2/5 plus 1/4 is 0.65, which is 65 hundredths, or you can math frac it and get 13/20. So let's do that. 13/20. If you're not good with math, use your calculator. In case you want to know, we would multiply top and bottom by 4. Here we'd multiply top and bottom by 5, and that gives us 8/20 plus 5/20, which is how we got 13/20. Please, it's so important that you know how to get a common denominator in order to add fractions, so please do that. So 12x to the 13/20 is a perfect answer. It's totally fine. All right, we got a little division problem. Again, here, 48 divided by 12 are just numbers. So I can just divide those, reduce it like a fraction. 12 goes into 48 4 times. And then we have here, these have the same base. So I'm going to keep the base the same, and I'm going to subtract my exponents. Top minus a -1/4. Which means that we, again, need a common denominator. So I'm going to multiply top and bottom by 4. This fraction, I'm going to multiply top and bottom by 3. So that becomes 4/12 minus a negative is really plus 3/12, which is 7/12. So 4 times b to the 7/12, which is a great answer. With or without that dot, totally fine. Letter C, again, I want to clean up inside the parentheses if I can. Before I deal with that power. So I can't right now do anything with the 6/7, so it's just going to say 6/7. Here I have x. Oh, I don't have another x. Oh, look at that. So I'm just going to leave x to the 2/5. Can't do anything with that. I also can't do anything with this y. So y to the 2/3 is going to stay. But I can clean up my b's. I got a couple of b's on top and bottom, so we're going to clean that up. Clean up whatever you can. So the base stays the same, and again, it always goes in the numerator when you're applying the subtraction property. That's going to be top minus the bottom. 2 minus the -4 is 6. All right, that's all I could clean up there. And so now I'm going to make sure I send that power to a power we multiply. Everything has its own little exponent. So I want to make sure that everything gets multiplied by 2. So share that power everywhere. 6 squared This is x. We're going to multiply 2/5 times 2 becomes 4/5. When you multiply fractions, you multiply straight across. So that looked like 2/5 times 2. Well, that's 2/1. So you multiply straight across. 2 times 2 is 4. 5 times 1 is 5. Here we have b. 6 times 2 is 12. I'm going to do the same thing to the bottom. We've got 7. 1 times 2 is 2. And here, 2/3 times 2 is 4/3. And that's all we can do. All of our exponents are positive. So, oh, actually, we could do one more thing. Sorry. This is a great answer, but probably since they're just squared, you would just multiply that and get 36. X to the 4/5, b to the 12th over 49, y to the 4/3. And this is a fantastic answer. You could absolutely have gone from here to here. You know that this would be 6 squared. 6 squared is 36. All right. Again, this is just really great practice with adding and multiplying fractions. So please make sure you know how to get a common denominator and that when you multiply fractions, it's just straight across. Don't get complicated, just straight across. And of course, you can use your calculator also. We could have done 2/5 times, not 5, times 2. 2/5 times 2, again, is 0.8. And you can math frac it, which gives you 4/5, which is what we got. So you can use your calculator. You just need to be a little careful about it. All right, ladies and gentlemen, you have the Rational Exponents worksheet. Again, you can find it in Clever on the calendar that you just clicked on. And again, if you, that says calendar. All right, you can print it. You can handwrite it, but do check your answers and you will submit, upload it to the Student View Dropbox, the proper Student View folder, okay, or proper Dropbox. All right, and again, try and get that done today. STUDENT, View. All right, upload that to Student View as soon as you can, but definitely by Sunday. Folks, have a great day. Oh, also make sure you take your pictures. Check your pictures. Make sure that you can read your pictures. That's a check mark. Check your pictures. Because if you can read the picture, I can read the picture. So be very, very careful. Thanks, guys. Have a great day.